Welcome to the deep dive. We're here to take complex stuff and really distill it down for you, make it clear. And today, we're plunging into artificial intelligence, AI. It's everywhere, isn't it? Shaping our future. But honestly, it's often really misunderstood. You hear these extremes, like
Yeah.
AI is cute and fuzzy, or it's a potential mass murderer. Just wild swings. So our mission today is to cut through all that noise, all the hype.
Exactly. We want to explore what AI actually is, what it's definitely not, and how it connects to the tech you use every single day. We're drawing a lot from Artificial Intelligence for Dummies. Second edition is great because it takes this really balanced, middle-of-the-road approach, helps clear away the hype and, well, the negativity, too. Gives you a much clearer view.
Right. So let's separate fact from fiction, what's real, from maybe an overactive imagination. Our goal is for you to walk away feeling well-informed with a really crisp understanding of AI, maybe even appreciate its role a bit more. Okay, let's unpack this. We're just constantly see AI in movies, TV shows, books.
Yeah.
HAL 9000, the Terminator, powerful images. And we humans, we tend to anthropomorphize, right? Give human feelings the thoughts of technology. And that combo, the pop culture plus our own tendencies, it really seems to create false hopes, unrealistic expectations. So maybe the first big question is, when you strip all that away, what is AI really?
That's the perfect place to start because the reality is much less dramatic, maybe, but still totally fascinating. At its core, AI is a simulation. It's not actual human intelligence itself. When we talk about our own intelligence, we mean complex stuff like, learning, reasoning, understanding things, seeing connections, telling fact from belief, experiencing emotions. Now, computers can mimic some of this. They use algorithms, they manipulate data, they can set a goal, assess information, work towards that goal. But and this is key, they're severely limited. A computer is technically incapable of understanding anything. It's all just math, pure math, done mechanically.
Ah, okay. So it looks like understanding, but it's not actually comprehending, like an illusion.
Exactly. And that's the huge difference between what we call weak AI and strong AI.
Huh.
And here's the thing. All AI today, everything you use, everything researchers are working on that's functional, it's all weak AI. It doesn't understand anything in the way a person does, not even close. What you're seeing, even with these really advanced chatbots or image generators, is just incredibly clever programming. It simulates thought using rules, finding patterns, calculating probabilities, but true comprehension. Consciousness.
Yeah.
Nope, not there.
That distinction feels so important for keeping our expectations grounded. It makes me think of the Wright brothers. They didn't build a plane by making an exact copy of a bird flapping wings and all. Instead, they studied the principles, aerodynamics. They wanted to fly, but they found a totally different way to do it. Is AI kind of like that? Achieving intelligent results without copying human thought directly?
That's a fantastic analogy. Yes, absolutely. AI aims to achieve intelligent goals, like, say, recognizing your face to unlock your phone or translating a web page, but it gets there using completely different methods than your brain does. It's engineering solutions that look intelligent, not replicating our biological wetware. And that's why we often talk about AI based on what it does, like acting humanly, passing the Turing test maybe, where you can't tell it from a person in conversation, or just thinking humanly, doing tasks that normally need human intelligence, like driving a car.
Okay, so if it doesn't think like us and it's this simulation, how does it actually work? How does it take data and, do something useful? What are the basic ingredients?
Right, it boils down to three main things: data, algorithms, and specialized hardware. And the absolute bedrock, the fuel for it all, is data.
Data. Feels like we can't escape that word these days.
Huh, no kidding. And there's a good reason. Data is truly the universal resource for AI now. This whole big data revolution, it's not just some buzz phrase, it's real. AI needs massive, complex amounts of data to learn and function. That includes structured data, like you'd find in a neat spreadsheet, but also unstructured data. Think text messages, photos, videos, audio recordings, all of it. When your credit card company calls you about a weird purchase?
Yeah, that's happened. Saved me once, actually.
That's AI. It's embedded right in their system. It spotted a spending pattern that didn't look like you and flagged it. It's protecting your finances by seeing anomalies in the data. Pretty amazing, right? Often working behind the scenes.
It really is. Those hidden applications are everywhere. But okay, data is the fuel. What about its quality? The source book mentions mistruths in data. That sounds problematic.
Oh, it's hugely important, critically important. See, humans, we deal with opinions, nuance, context, lies even, all the time. We sort of filter it. But a computer, it can't tell the difference between true data and false data. It just sees numbers, patterns, All data looks the same to it. And this inability to discern truth is a massive reason why AI can't think like a human. Think about these mistruths. There's outright lying that's called commission. Someone just puts in false info on purpose. Then there's omission. Telling the truth, mostly, but leaving out one critical piece, like, you report a car accident, road was wet, I braked late, a deer ran out. All true facts. But you admit you were texting. That missing piece changes everything, right? And AI might totally miss that if it's not explicitly told.
Wow, okay. That makes sense.
Then you've got perspective. Same event, different viewpoints.
A car accident, the driver sees it one way, the pedestrian another, a witness a third way. Whose truth is the truth? Or imagine being deaf in 1927. Silent films are amazing, then talkies come out, everyone says they're the best ever, but you feel excluded. What's true for everyone is often a myth. AI struggles with that.
So subjective experience is a blind spot. Definitely. And then there's bias. Personal beliefs, conscious or unconscious, that stop someone seeing the whole picture. Like a driver hyper-focused on the center line, missing the deer at the edge of the road. Humans have these filters that cause bias, and AI just processes the data it gets, biases and all, if they're baked into that data. And one more frame of reference, just misunderstandings because people lack shared experience. Try explaining a hurricane at sea to someone who's never left Kansas. It's hard, right? AI has zero lived experience. It can't grasp things that require that kind of embodied knowledge. So because AI can't spot all these potential mistruths, lies, omissions, perspectives, biases, lack of context the data it uses, it always has some deficiency, always. That's why human oversight, human review is so often absolutely essential. You need a person to check its work, especially in high-stakes situations.
That really drives home why the next piece, how AI processes that imperfect data, is so vital. So let's talk algorithms. What are these recipes that make AI actually do things?
Yeah, simply put, an algorithm is just a series of steps to solve a specific problem. Like, think of a recipe for baking bread. Very precise instructions. But where it gets really exciting is machine learning. This is where the computer isn't just following a static recipe. It actually learns from data itself. So instead of a programmer writing explicit rules for every single possible scenario, you show the machine examples, lots and lots of examples. It's a bit like teaching a child by showing them how to behave, letting them learn from experience rather than writing a giant rule book for life. The big dream, way off in the future maybe, is a master algorithm, one algorithm that could learn basically anything from data. But we're not there yet.
And within machine learning, we hear a lot about deep learning. That seems to be behind many of the big AI headlines lately.
Deep learning is a specific, more complex type of machine learning. It uses structures called neural networks, which are loosely inspired by the network of neurons in the human brain, only loosely, mind you. Imagine like a multi-stage water filter. Water goes in the cup, passes through different layers, each filtering out different things. It only flows forward. In deep learning, data features flow through layers of the network. At each layer, features are combined, transformed, creating new, more complex features. This helps the network get better and better at making predictions or classifications. This is the tech behind a lot of the really cool stuff, recognizing objects in images with high accuracy, understanding natural language, translating between languages almost instantly.
Okay, so you have the data,
Yeah.
you have these learning algorithms, but none of it happens without the raw power, right? The hardware must be critical.
Oh, absolutely critical. Many early AI ideas from, say, the 60s and 70s, they just fizzled out, partly because the computers back then simply weren't powerful enough. The hardware couldn't keep up with the computational demands. Today, that's changed dramatically. Processing power has finally caught up to the ambition of the algorithms. Standard computers, your laptop maybe, often use what's called a von Neumann architecture. Memory and processing are separate, and data has to shuttle back and forth, creating a kind of bottleneck.
Yeah.
For heavy-duty AI, especially deep learning, we often use specialized hardware, things like graphic processing units, GPUs. Yes, the same chips that make your video games look amazing.
Really, gaming chips.
Yeah. Turns out the kind of parallel calculations needed for rendering complex graphics are very similar to those needed for training neural networks. So GPUs became essential. And big companies like Google have even designed their own custom chips, like tensor processing units or TPUs. These are built specifically for the massive parallel computations AI requires, making everything much, much faster.
Okay, this is where it gets really fun for me. Where does this stuff actually show up in your life? Often, like you said, without you even noticing, not just the big sci-fi dreams, but the everyday reality.
You are interacting with AI constantly, way more than most people think. Got a smart thermostat at home, one that learns your schedule, temperature preferences.
Yep. Got one of those?
That's AI, using machine learning to predict what you want. Voice assistants on your phone or smart speaker, Siri, Alexa, Google Assistant.
Do it all the time.
They learn how you speak, the nuances of your voice to understand you better. That's AI. We mentioned fraud detection on credit cards, classic AI pattern recognition, even things like resource scheduling in hospitals, figuring out the most efficient way to assign beds, operating rooms, staff based on patient needs. AI is often optimizing that in the background. Honestly, the uses run into the millions. Many are just quietly embedded in the software you use, making things run smoother, safer, or more efficiently.
It's genuinely mind-boggling when you start listing them, just woven into the fabric of things. But some areas see even more dramatic impacts, right? Like medicine seems like a huge one.
Medicine is a perfect example. AI can provide consistent, logical, and unbiased help. That's incredibly valuable when health is on the line. Look at portable patient monitoring. Wearable devices like maybe a fitness tracker like Move or an Oura Ring tracking sleep chat. They monitor heart rate, activity, sleep quality. They give you feedback. Or devices like the K-Watch for diabetics, constantly monitoring glucose levels. No more constant finger pricks. It makes managing the condition so much easier. This tech gives doctors crucial data continuously, not just snapshot from an office visit.
That makes a huge difference for treatment.
Huge. And think about physical assistance. AI-powered exoskeletons. These can help people run faster, lift heavier loads with less strain, or even help someone walk again after an injury or stroke. They reduce stress, keep people mobile. And then there's drug discovery. This is amazing. Companies like Atomwise use AI to sift through vast databases of molecules. They predict which ones might actually work to treat a disease. Back in 2015, they used AI to help identify potential Ebola treatments in literally one day. That kind of task would normally take teams of human researchers months, maybe years. It's revolutionizing how we find new medicines.
A single day versus years. That's incredible. Life-saving speed.
Yeah.
And communication, you mentioned the assistants, but translation too.
Absolutely. We talked about chatbots like Siri and Alexa. Remember, when you talk, they turn your speech into numbers, match patterns, find the best response pattern. It feels like understanding, but it's that clever programming again. Google Translate is another great example. Their newer system, GNMT, it can actually translate between language pairs it wasn't specifically trained on. Like if it knows English to Japanese and English to Korean, it can sometimes figure out Japanese to Korean by using English as a kind of universal bridge. This massively improves translation quality and helps break down communication barriers globally. People can connect and understand each other much more easily.
Okay, what about the things that maybe get the most press? Robots and self-driving cars. Are they everywhere yet?
Well, industrial robots certainly are, just maybe not where you see them. The first one, Unimit, started working on a GM assembly line way back in 1961. They've been doing dangerous, dirty, repetitive jobs in factories for decades. Welding, painting, moving heavy things. Unsung heroes of manufacturing. Then you have mobile robots, ones that can go places humans can't or shouldn't, exploring damaged sewer systems, cleaning up radioactive waste after disasters like Fukushima, saving human lives, and drones, of course. Whether military reconnaissance or Amazon and Google experimenting with package delivery, AI is making them more autonomous, able to sense obstacles, navigate complex environments, fly safely without constant human control. That's unlocking huge potential.
Right. And the ultimate mobile robot, I guess, is the self-driving car. That's what everyone seems fascinated by or maybe worried about.
Definitely a hot topic. And while true level 5 autonomy, where the car drives itself anywhere, anytime, any conditions, no steering wheel needed, that's still quite a way off, probably, major hurdles remain. But AI is already deeply involved in cars today. It's enabling cars to perceive their surroundings, navigate roads, detect pedestrians and other cars, read traffic signs. It uses sensors like cameras, LiDAR, radar, and AI algorithms process that data. The potential benefits are massive, drastically fewer accidents, since most are caused by human error. Lower insurance costs, smoother traffic flow, and think about getting back all that time you spend commuting. You could work, relax, read. Even now, the driver assist features in many new cars, automatic emergency braking, lane keeping assist, adaptive cruise control, those are powered by AI and are already making driving significantly safer, especially in tricky or dangerous situations.
So AI can do some truly amazing things. Almost feels like magic sometimes. It's clearly not just cute and fuzzy, and thankfully not the mass murderer scenario either. But what does this all actually mean for us, for humans? Are the fears about AI taking over, replacing all our jobs? Is there anything to that? What does this mean for you listening?
Yeah, that's the million-dollar question, isn't it? And it's where we really need to cut through the hype and, frankly, the fear-mongering. The single most important thing to remember, the core takeaway, is this. AI doesn't understand anything. not in the human sense. It processes numbers, it finds patterns in data, it generates outputs based on that data, and incredibly clever programming. But it has zero feelings, zero self-awareness. It doesn't know what it's doing.
So that lack of genuine understanding is fundamental.
Absolutely fundamental. Like we said, it turns everything, words, images, sounds, into numbers. It can't grasp the meaning, the substance, the emotion behind your words. It's just matching patterns. Very sophisticated pattern matching, but pattern matching nonetheless. And because of that, AI is not creative or intuitive like humans are. It tends to stick with what it knows, what's in its training data. Humans, we constantly extend the envelope of what is real by making the unreal possible. Think about the Wright brothers. Again, flight seemed impossible, foolish even, until they imagined it and made it real. That kind of leap, imagining the unreal and making it reality, that's uniquely human. AI can't do that.
Okay, no real understanding, no true creativity.
Yeah.
What else?
No empathy, no moral judgment. Since computers don't feel, they literally cannot see things from the perspective of a human. They don't comprehend happiness, sadness, fairness, suffering. If you ask an AI to make a purely logical choice based on data, it will pick the option with the highest statistical probability of success, whatever that means in context. It won't consider the ethical or emotional fallout unless a human has explicitly programmed rules for that. This is the core of the famous trolley problem thought experiment applied to self-driving cars. How should a car be programmed to react in an unavoidable accident scenario? And AI can't make that moral judgment itself. It needs human instructions, human values programmed into it. And one more thing, AI can't really discover new principles. It's great at interpolation, finding solutions or patterns within the boundaries of its existing knowledge. But it struggles hugely with extrapolation, taking existing knowledge and creating genuinely new knowledge, new theories, new ways of thinking. It can't really see a situation as fundamentally unique or devise truly novel approaches that aren't based on patterns it's already seen. That requires human insight.
So all these limitations, they actually highlight how important humans remain. It's not about us becoming obsolete.
Exactly. You could argue AI actually makes humans even more important. It takes over the mundane, the repetitive, the dangerous, the purely calculation-based tasks. That frees us up to focus on what we humans do best. Complex interaction, collaboration, creativity, invention, emotional intelligence, intuition, ethical reasoning. So if your job relies heavily on those uniquely human skills, think nursing, teaching young children, scientific discovery, artistic creation, therapy, even complex detective work that requires that illogical leap, that gut feeling your job isn't just safe, it's likely to be enhanced by AI tools. AI is a tool, a profoundly powerful tool, yes, but designed by humans for humans to augment our capabilities, to help us solve problems too big or complex to tackle alone. It's meant to be a partner, not a replacement.
We've covered a lot of ground today. We started by demystifying AI, what it is, what it isn't. Looked at the core ingredients: data, algorithms, hardware. We saw some incredible uses, many hidden in plain sight in your daily life. And crucially, we highlighted its limitations, reminded ourselves that it's a tool, a powerful one, but still just a tool.
Right. And the big takeaway really is AI isn't here to replace us. It's here to augment us. The future isn't just humans and AI existing separately. It's about humans and AI truly collaborating, working together. Imagine, down the line, AI helping us tackle huge challenges. Not just understanding climate change better, but maybe even helping us terraform other planets, make them habitable. That's a wild thought. Or think about brain-computer interfaces, letting our minds connect directly with AI in ways we can barely conceive of now. Blurring that line between thought and digital action, unlocking totally new ways for humans and computers to work together.
So far from being pushed aside by AI, maybe we're evolving with AI, learning to work alongside it to do amazing things we couldn't even dream of in the past. That really flips the script, doesn't it? So here's something to think about. What new possibilities do I imagine emerging when humans and AI truly collaborate? That's a future worth pondering.